Our goal is to solve this initial value problem. The very first question is this a separable differential equation? So let us try to separate the x terms from y terms. You get x squared dy over dx. On the right-hand side, if you factor out y, you end up with 1 minus x. So you can easily separate this as, let me use a different color, dy divided by y, and on the right-hand side, you have 1 minus x divided by x squared times dx. Very good. So since it's a separable differential equation, you're going to take the integral of both sides. The integral on the left-hand side is easy for you. You have dy over y, which is going to be ln of absolute value of y. On the right-hand side, you're going to do a little bit of manipulation. You're going to write it as 1 divided by x squared minus x divided by x squared, and then take the integral. On the left-hand side, you end up with ln of absolute value of y. On the right-hand side, you have negative 1 over x and negative 1 over x gives you minus ln of absolute value of x plus constant of integration. Very good. So you can rewrite this as well. You can bring all ln's to one side and then use the property of ln of absolute value of y minus ln of absolute value of x going to the right-hand side gives you plus ln of absolute value of x. And on the other side, you have negative 1 over x plus constant of integration, which is c. Remember that when you have ln of a plus ln of b, this is ln of a times b. So the combination of these two is ln of absolute value of x times y, and on the right-hand side, you have negative 1 over x plus constant of integration. By definition of your ln, the absolute value of x times y is equal to e to power negative 1 over x plus c, which also can be written as absolute value of x times y equals to e to power negative 1 over x times e to power c. Getting rid of absolute value, you end up with plus minus sign. On the left-hand side, you have xy, and on the right-hand side, you get plus minus because of absolute value, and you have e to power negative 1 over x times e to power c. We can combine these together and rename it as c sub 1. So let us take c sub 1 to be plus minus e to power c relabeled. So x times y is equal to e to power negative 1 over x times c sub 1. From initial value problem, we know that y at negative 1 is equal to negative 1. So let me copy this guy down. This helps us to find the value of c sub 1. So using the initial value here help us to find the actual value of C sub 1, and this general solution becomes a particular solution. The general solution becomes particular solution. So let us begin. X is equal to -1, y is equal to -1 as well. So let me use different color here. X is -1, y is -1, coming from the initial value. So let us plug those in. On the left-hand side, -1 times -1 is equal to e to power -1 divided by -1, which is +1, times C sub 1. Very good. So C sub 1 is equal to 1 divided by e, or to power -1. Very good. So the particular solution can be written as x times y equals to e to power -1 times e to power -1 over x. You could combine these two as well, or isolate y as well. So let us isolate our y. Your y becomes e to power -1 times e to power -1 over x divided by x, or y can be written as e to power -1 minus 1 over x divided by x, and this is the solution, particular solution of the differential equation. You could also write it this way as well. Y is equal to e to power -1 plus 1 over x divided by x. You could just take the common denominator as well, but either of these are fine. So let us recap what we did. Question says, solve the following differential equation. It has initial value. It says, whenever your x is -1, your y becomes -1 as well. First of all, we showed that this is a separable differential equation. We took the x to the other side. We divide everything by x squared, and we brought y to the left-hand side as well. So you end up with dy over y equals to 1 minus x over x squared dx. Indeed, it's a separable differential equation, so we can take the integral of both sides. The integral on the left-hand side gives you ln of absolute value of y, and the integral on the right-hand side gives you -1 over x minus ln of absolute value of x. Then we brought this ln to the other side, so we can combine these ln's using the property of ln. So you end up with ln of absolute value of xy equals to -1 over x plus c, or absolute value of x times y is e to power -1 over x plus c. But you can separate these two as e to power -1 over x times e to power c, and then get rid of the absolute value sign by end up having plus minus sign on the right-hand side. We relabel plus minus e to power c as c sub 1. We introduced a new constant, and we get xy equals to e to power negative 1 over x times c sub 1. But using the initial value, you know that when x is negative 1, your y becomes negative 1. It helps us to find the value for c sub 1 and get particular solution out of it. So we check this and we showed that c1 is e to power negative 1. We substitute this guy back into the general solution of the differential equation. And we also isolate our y, as you can see here. Isolate y to get an explicit solution. Now you can use Desmos or any other graphing device that you're using and visualize this particular solution.